Hello, my name is Abdeslam. I am a NEF fellow representing Morocco, and I am a professor of social sciences at Mohammed V University in Rabat. I'm very delighted to take part within the NEF Global Gathering 2020, which is taking place this year in extraordinary circumstances. Yet, this does not hamper us from getting together and celebrating science within Africa. In the world of business, within every challenge lies an opportunity. The COVID-19 pandemic is no exception. For Africa, it has been a wake-up call for all African nations and people to leapfrog toward the fourth generation. We need to remodel our practice and also our implementation of scientific excellence, the kind of excellence that drives progress and economic transformation. And what do we think of when we think of scientific excellence? Well, the data suggests that most people, including scientists, think of research excellence. And here we have so much to celebrate. Since 2014, the World Bank has been celebrating a number of governmental and national establishments and collaborations. For example, there is 22 centers of excellence in West and Central Africa, and then 22 hubs in Eastern Africa, and then the grassroots to found 46 excellence center in 17 countries. All these initiatives are great. However, they are not enough because they are not going to lead Africa where it needs to go. Scientific excellence alone will not help us increase the research output and investment in R&D into more than 1%. And alone, it's not going to deter the 70,000 brain drain and young researchers who leave Africa every year. And alone, it is not going to reduce the gender gap because women represent only 30% of the general scientists in all fields in Africa. And alone, it is not going to respond to the need of 11 million young people who graduate every year from the 54 countries within Africa. It is high time to start collectively devising our own model of scientific research and research excellence. A model that allows an inclusive environment that helps generating more thinkers, more philosophers, more humanists and social scientists, inventors and researchers. This is a generation of researchers and scientists whose daily concerns are responding to the daily need of their local communities. Cultivating this model of scientific excellence will give us Africans the opportunity to progressively make research and development go beyond one, and it will also increase research output, increase scientific capacity at an early age, say for example K-12 and under-demand skilled youth. Move from a grant-based position to a tenure-track position and founding research and research program which will help turning brain drain into brain circulation. Providing childcare in the labs and more flexible working environments and extended maternity leave, which should encourage more and more women to enter the scientific field. What I'm trying to say is that when we make it possible to put scientific knowledge and skills of Africa's men and women in the service of their social, environmental, economic, and political communities, only then we can speak of scientific excellence that would leapfrog Africa and African communities toward the fourth revolution and the fourth generation of science performance. Finally, let us not forget that if this forum is called Einstein, it is in order to acknowledge what Einstein has offered to humanity. Remember that he was emboldened to think outside the existing system and stood nearly alone as the pinnacle of science. Excellence in all its form, theoretical, practical, and humanitarian, were represented by this personality. So let us be inspired by his spirit. Thank you very much.
My name is Marian Asantua Nkansa, an Associate Professor of Chemistry at the Kwame Nkrumah University of Science and Technology in Ghana. I would like to share with you a topic that has been on my mind for some time now. That is Africa a favorite destination for global e-waste? Electronic and electric equipment can be simply defined as products which require a power supply or battery use in order to function effectively. And this can include computers, refrigerators, cell phones, and others. An equipment is classified as e-waste or waste electric and electronic equipment when the owner discards it as a whole or its parts without any intention of reuse. It is estimated that in the year 2017, the global e-waste that was generated was about 50 million tons, and it has been extrapolated to cover about 52.2 million tons in the year 2021. Out of the waste that was generated in 2017, only 10% was recycled. The remaining 60 to 90% were exported to Africa and Asia, with Ghana and Nigeria, Ivory Coast and the Democratic Republic of Congo topping the list for Africa. E-waste movements to developing countries follows informal routes. They are sold as second-hand or scrap or sometimes other illegal routes that are not known. And it's said to contribute to about $19 billion to the patrons. E-waste contains highly toxic substances that are harmful to humans and also to the environment. However, the products can also have components that can be repaired, reused, and even sometimes recoverable precious metals like copper. The movement of e-waste to least developed countries is a growing trend which seems to have no end in sight. But there is ready market, and the lack of regulations and enforcement in most cases makes it thrive. There's also a general preference for second-hand versions of high-end brands which appear to be more durable and cheap compared to imitations of the same brands which are brand new. The e-waste industry is a vibrant part of the informal sector in most developing countries, and the practice thrives due to the improved livelihood it offers patrons and the service providers. It is estimated that about 2,000 and 15,000 tons of electric and electronic equipment are imported to Ghana every year. Out of this number, 30% are brand new and 70% are second-hand. Out of the second-hand products, 15% are outdated or broken down and have no use, so can be considered as scrap. Among the second-hand goods that are distributed in Ghana, those that can be sold as a whole are distributed for domestic and industrial use, and others go through sorting and also processing of spare parts for use, dismantling, and then extraction of precious metals. All these processes are done under very dangerous conditions because workers have no recourse to their personal safety or the safety of the environment in which they work in. Research over the past decade has focused on analysis of air, soil and water bodies within the catchment areas of the sites. The research over the years has focused on analysis of air, soil and water bodies within the catchment areas, and also urine and blood samples of workers. Studies have confirmed elevated levels of pollutants such as aromatic hydrocarbons, lead, arsenic, cadmium, chromium, and other toxic substances. These pollutants can cause organ failure, cardiovascular diseases, and even cancer. Ongoing research study by my team has also confirmed these substances that I've already mentioned, and also include flame retardants, which can cause hormonal changes, fertility problems, and even cancer. The situation is not all that gloomy. There's been interventions as far as Ghana is concerned. In the year 2011, Ghana developed an e-waste strategy which was focused on conformity assessment, technology partnerships, financial mechanisms, and also the establishment of national recycling centers, among others. Now, my parting words to everybody listening to me now is that e-waste trade in Africa can be considered as a double-edged sword. It can be regarded as a helpless situation with its associated health and environmental hazards, or a useful resource that can be harnessed.
Hi, my name is Samson Rawire. I'm the Director of Graduate Studies, Research and Innovations of BADRE University. I'm also an Associate Professor of Materials Engineering at the Department of Polymer, Textile and Industrial Engineering of BADRE University. Before I returned to Uganda, I was developing aerospace materials, and this is carbon fiber reinforced plastics and glass fiber reinforced plastics. These materials were for aircrafts, especially for companies like Airbus, Eurocopter, and Boeing, to mention but a few. So when I returned home, I thought of what can I use the aerospace knowledge, the one I had training in at master's degree level, and then use the local materials which are available for me in Uganda. And that's how I thought of nano-inspired materials based on the local market, on the local aspect. And if we are thinking of innovation, it tends to move very slowly. But if we think of Sustainable Development Goals, specifically SDG number 11, sustainable cities, then that means that in 1 out of 2 people will live in cities by 2030, and by 2030, Africa will have 1.6 billion people. And in that particular aspect, there will be a need of sustainable cities and communities. And that is where we think about the materials we are going to use. We have been developing nano-inspired materials based on the nanotechnology, and they've been applied in the industry, for example, in roads or in health sector or any other industries. Specifically for roads, we looked at our roads, especially which we have here in Uganda, and one of the challenges we have is that the roads, when not sustainable enough, they don't last longer, and that's why we thought of coming up with a solution. And one of the solutions was using biomass. If you look at biomass, we can get lignin and convert it into nanophase, nanolignin. And this lignin, it acts as a cross-linker for one of the other problems which we have been having in the community of waste plastics, because there are very many plastics in the environment and they're affecting the environment. So we thought that we can remove the plastics from the environment and use nanolignin as a cross-linker, and then we use it as a binder in road construction. Because one of the challenges is that in road construction is that the bitumen is imported into the country, and it also increases the cost of road construction. So if we use plastics and nanolignin to bind, use it as a binder, that means we can construct roads with less bitumen, and then the roads themselves will be durable for a long period of time because they'll be water resistant, and they will also, the lifespan will increase, they will be pothole free. And one another challenge, when we look at Uganda, we produce a lot of food, but 20 to 30% of the food which is produced globally goes to waste because it is dumped or it gets rotten. But if we get the food materials themselves and then convert the food into nanocellulose, then we can produce sustainable packaging materials for packaging food. And in that particular aspect, for example, you can use the particular packaging to wrap your food and incorporating biosensors still from the environment, not chemicals, and then it can be able to show the consumer whether the food is good for consumption or it's not good for consumption. But Africa as a continent cannot be left behind. We don't want to be left behind in terms, for example, in GMO-based products which are produced in particular countries and then other countries don't have policy. We want to look at nanotechnology or nano-inspired products which can be used for sustainable development of communities and countries, specifically in Africa, whereby if we have a binding policy, we can bring African scientists together in terms of research and development. It can help us as developing new materials for sustainable communities. And this policy, we cannot leave it out because the policy will help us as scientists to come up with new materials. And we think that nano-inspired products can be used for cancer treatment, for example, in terms of drug delivery, can be used in road construction, can be used for food packaging, and the future is bright with nanotechnology using local-based materials. And I believe African scientists are going to take this as important for the development of the continent. And come 2030, when we have sustainable cities and communities, nanotechnology will play a vital role. Thank you very much.
Hello, I'm Dr. Blessing Mbabe Oyedemi, a research fellow and a lecturer affiliated with Michael Okpara University of Agriculture in Nigeria and Trent University of Nottingham in the UK. And my passion is leading research in the area of antimicrobial resistance and drug discovery. It's become a reality, the looming problem of ineffective antibiotics due to multi-drug resistant bacteria, and Africa is the greatest hit, second to China. By 2050, we might be recording 4 to 15 million deaths every year, and that means one person dies every 3 minutes. And Africa will definitely have drastic effects in this problem, such as countless deaths, poverty, impoverishment, and reduced productivity. While we are slow in trying to discover new drugs, the smart box are busy dividing in millions every 20 minutes, such as MRSA, E. coli, Pseudomonas, and the rest of them. So my work therefore focuses on discovering and developing promising antibacterial drugs, such like we've had in the past medicinal plants that have yielded great drugs such as aspirin, artemisinin, or even quinine. So an example of a plant-based compound from our research in the lab is capsaicin. And capsaicin has demonstrated broad-spectrum antimicrobial resistant mechanisms such as anti-staphylococcus, anti-plasmid, and anti-biofilm potentials. So developing this area of drug development is very crucial in Africa because the bugs are getting smarter and the antibiotics are getting less effective. Traditionally, African nations have had to outsource the development of new drugs and bringing them into markets. We are only but raw suppliers of raw materials and never manufacturers. But I'll tell you that this is really changing for three big reasons. First, the scientific capacity and the expertise is greatly enlarging in Africa, even though it's not all home yet. Secondly, the market pipeline is empty. In 2019, about 52 antibiotics were developed they were under development, and 10 of them were biologicals, but they never made it to the market yet. The third reason is that the big pharma landscape is changing rapidly. It's not as profitable to develop short-term drugs like antibiotics compared to long-term lifestyle drugs for, say, cancer or diabetes. And also, companies tend to make these decisions based on the data that is gathered on such prevalences. But we know that in Africa, there is scarcity of data in antimicrobial resistance surveillance in the CDC website. So if Africa continues to be consumers rather than producers, many potential solutions will never get the investment that they needed to make it out of the lab, let alone it becoming in an affordable price. So we really require a new paradigm to be able to beat African smart bugs. And such promising plant-based compounds like capsaicin, which I've mentioned earlier, is commonly found in our chili pepper. For instance, the Nigerian chili pepper, which is found in my mother's homemade concoction. And this points to the fact that they possess numerous chemical hits that can be harnessed for further development. That does not mean that if you consume a lot of chili pepper, you're going to get well. But what it does point out is the untapped medicinal capacities from our natural plant remedies. And this creates a very huge African biopharmaceutical industry and also enables us to develop drugs that are cheaper, affordable, and accessible instead of waiting for a cheaper generic drug to come downstreams to beat the African smart box. The global market for natural medicine product and drug market, is increasing, and the interest is growing rapidly up to the point of 18.2% in up to 2024. And this is a very huge market for the African medicinal plant products. Plants continue to remain super chemists, and they are used by over 80% of the African population. And they continue to live and even outlive humans and mammals. And they have the competitive advantage over smart drugs. So any new drug needs this understanding forged in a thousand fires of traditional medicine to be effective and to stay ahead of the smart box. So let us tap into the potentials of our very own natural resource, the medicinal plant, and start to develop them into affordable, cheap, and accessible drugs to fight antimicrobial resistance in Africa. Thank you.
I am Ikeria Oluchunwichi, an environmental biochemist of the University of Port Harcourt, Nigeria. I'm the AG Director for Exchange and Linkage Programs Unit of the University of Port Harcourt. It's exciting and reassuring that organizations like Next Einstein Forum NEF is excited about my work. My research passion revolves around assessment, monitoring, and remediation of impacted environments. The NEF challenge that my research is addressing is climate smart innovation. Why? Because my technology phytoremediation, which is the use of plants in recovering impacted soil environment, is actually sustainably giving enhanced productivity because of the resulting clean and safe water and soil that gives back to food for all. So our research has shown that increase in temperature had huge negative impact on the yield of common cereals in Nigeria, like the corn. So we have compared that with what we have after cleanup of soils by chemical means or even excavate and dump technology that are often being used, or some other physical like the thermal cleanup technology. So our technology is able to improve the temperature of the soil after recovery. I've cost-effectively remediated many impacted sites in the Niger Delta, where oil exploration and exploitation is at its peak in Nigeria. This is very important for small economies like Nigeria that are dependent solely or to a very great percentage on mining of natural resources, here crude oil. So this is my natural hub. I don't need importation, I don't need exportation, I don't need preservatives, I don't need no toxic chemicals, I don't need high-tech expertise to get in here. So we get into the bush, we look out for some trace in plants, and we're able to identify them. Like here, I have my little plants, Centrosema pubescens. We have tried it, laboratory scale, and we have also done field application. And this is actually good for remediation of lead in crude oil polluted soil, because we have associated heavy metals whenever there are crude oil polluted sites. I've characterized several soils in the Niger Delta to understand the soil quality, especially the pH, because we found out that pH is a big factor in the movement of the contaminants through the soil. So it's important for us. And in this, I've got a patent for remediation of crude oil polluted soil, the acidic type, in the Niger Delta. So we've also tried to understand the nutrient composition so we can formulate soil conditioners for optimal growth of the plants that we're using in the technology. I've had recognitions in form of patent, like now I own a patent in the technology, and also of the Next Einstein Forum, the African Academy of Science, UNESCO, L'Oreal, Commonwealth, and many others have recognized me for my contributions in this field. There are challenges in deploying this technology. One of those will be low government buy-in, maybe because of the slow pace of the technology to recovery, and that's normal for biological technologies. They can support us with funding or institutional support to deploy transgenic technology to boost efficiencies of established plants in the technology. Again, we have either non-existing or weak policies in Africa for sustainable technologies in environmental regulation that needs urgent attention. We also need more researchers to work to list more hyper-accumulators for use in the technology. And finally, we have heavy reliance on non-native experts and non-native technology. I mean, from outside of the continent. We have a lot of African innovators. So we think African innovators are the right people to heal Africa and her land. My proposed plant-based technology has all it takes to heal Africa and also generate new bioproducts for the bioeconomy. You see that? The good news should not be carried forward only by government in policy making, but also by media houses, by journalists, by public and private sector in agenda setting, and for us, the researchers, to generate credible and robust evidence. Yes, restore our land, heal our land, rehabilitate our land.